Okay, so video number 2. Here we go. We're going to talk about how to solve equations with variables on both sides of the equal sign. All right, so let's start off. We'll do something nice and simple. Let's just look at something involving integers only first. So let's say something like 2x plus 15 is equal to 7x. Okay, so this is a little bit different than what we've seen before because we have variables on both sides of our equal sign. And because I've got variables in 2 spots, I can't really solve for just the one variable if I leave it on both sides. So my first thing that I'm going to do is I'm going to push all of my variables to one side of the equal sign. Now, it really doesn't matter which side you want to push your variables to, but we need to group them all together. My personal preference is to always get rid of the smaller of the 2 variables. I always want to get rid of the smaller of the 2 variables because then generally I can avoid working with negative coefficients. I find we make a lot more mistakes if we're trying to multiply divide by negatives. We tend to drop them. Okay, so the first thing I'm going to do is I'm going to get rid of the smaller of the 2 variables. So just like how I'm able to add and subtract a constant to both sides, I'm also able to add and subtract variables to both sides. So if I was to have 2 x's and then I take those 2 x's away, I would have nothing. It doesn't matter how big the x's are, right? If you think of it as you had 2 $5 bills and then you spent 2 $5 bills, you would now have no $5 bills, right? So I'm going to take away the 2x from both sides, and what happens is these ones here cancel. And when I look at what I'm left with, I still have 15 remaining on the left. And on the other side, when I have 7x and I subtract 2x, that leaves me with 5x. Okay, so now my equation says 15 is equal to 5x. And when I divide both sides by 5, we get that x must be 3. Okay, so nice, simple. Get rid of your variables from one side, push them to the other. Okay, some people have the habit of they always have to put it on the left because they think the variable always needs to be on the left. It doesn't. You can push them onto whichever side you prefer. I like to keep my variable having a positive coefficient because I tend to make fewer mistakes that way. Okay, now I do want to verify this solution, and we've always been doing left side, right side, and things have been pretty simple because on the left side and the right side, one of them has always just been a single value. But now on the left side, originally I had that for my equation, and on the right hand side, I had 7x. Now I have variables on both sides. So now I actually need to do work substituting back in for each variable. So it's not as clear right away that they're going to be the same value. So 2 times 3 instead of x would give me 6, and 6 plus 15 is 21. On the right hand side, when I substitute x with 3, 7 times 3, that also gives me 21. And I can see now that I have the same value on both sides of the equal sign. Okay? All right, let's do another one. All right, let's make the values a little bit more difficult here. Why don't I go 0.2p is equal to 0.5, and then we'll go like this. We'll put a p in brackets with a constant. Okay, so with this one here, again, I've got p's on both sides of the equal sign, so that's no good. Now, as we saw in our last lesson, we had to take that number in front of a set of brackets, and we had to multiply that number into the brackets using the distributive property. So the first thing I'm going to do is I'm actually going to remove my brackets by multiplying that 0.5 in. So I now have 0.2p is equal to 0.5p, and 0.5 times 30 is going to give me negative 15. Okay, Now I've got variables on both sides, but since it's not stuck in a set of brackets, I can pick a side to add or subtract my variables. Okay, I'm going to put both of them, in this case, onto the left-hand side, just to show you that it doesn't matter which side I put it on. So last one it was on the right. This one we'll put them onto the left. Okay, but here we've got 0.2p minus 0.5p, so looking at just the coefficients, 0.2 minus 0.5 is going to give me negative 0.3, so I have negative 0.3p. On the other side, I'm left with negative 15. Okay, so I have to be a little bit more careful here because my opposite is now to divide both sides by the negative 0.3, and that's that negative sign that will trip you up from time to time. So that's why I try to avoid it. Okay, so negative 15 divided by negative 0.3, two negatives give us our positive, and then 15 divided by 0.3 ends up giving us 50. Okay, so to verify that we have the correct solution, again, we had information on both sides of the equal sign. So we had 0.2p on the left side, and we had 0.5 times p minus 30 on the right-hand side. So I'm going to put in, instead of p, I'm going to substitute in my value of 50. And 0.2 times 50 gives me, oh my goodness, sorry, 0.2 times 50 gives me 10. Okay, on the other side, instead of p, we're going to substitute in our 50. We substitute it in a set of brackets, and 50 minus 30 in that brackets gives me 20, and 0.5 times 20 is 10. Okay, so we have the same answer on both sides, so that means we have the correct solution. Okay, we'll do one more. I'm going to save the last example for another video just because it's going to involve some fractions and a little bit more work. So we'll go with 12x plus 7 is equal to negative 9x minus 24.5. Okay, so again, I'm going to go back to my preferred method of getting rid of the smaller of the two variables. So between the two things, I have positive 12x and I have negative 9x. So if I'm looking at the two variables, positive 12 is a larger coefficient than negative 9. So I'm going to get rid of the negative 9x, and I do so by adding 9x to both sides. Okay, my 9x's are going to cancel on the right, and now I have 21x plus 7 is equal to negative 24.5. I'm going to then get rid of my constant from both sides by subtracting 7. This leaves me with 21x is equal to negative 31.5, and then dividing both sides by my coefficient 21 gives me that x is equal to, on the other side, negative divided by positive is negative, and 31.5 divided by 21 is 1.5. And if you don't believe me, double check your calculators. Let's quickly check to make sure we have the right answer. Okay, so I'm going to go 12x plus 7 on the left, and negative 9x minus 24.5 on the right. So go back to your equation as it was originally before you started doing anything to it. So instead of x, I'm going to fill in negative 1.5. I don't know what happened with that decimal point there. 1.5. Okay, and we'll add the 7. 12 times negative 1.5 is going to give me negative 18, and negative 18 plus 7 is negative 11. Okay, negative 9, and instead of x, I'm going to fill in the 1.5, and then subtract the 24.5 after. Okay, 9 times, sorry, this was supposed to be a negative 1.5. See, this is where you catch all your mistakes. Negative times negative is positive. 9 times 1.5 is 13.5, and when we subtract 24.5. From 13.5, we have negative 11, giving us the same value on both sides of the equal sign. So when you've got variables on both sides of the equal sign, your first goal is to get all of those variables onto one side, either the left or the right, doesn't matter. Generally, I try to get rid of the negative, I try to get rid of the smaller of the two variables. So look at the coefficients for your variables, push them to the left or the right based on whichever one is smaller, and then you solve your equation like normal. All right, thanks.